Good day, grade 12s, and welcome back to the continuation of this lesson 5. And in this lesson, boys and girls, we essentially be looking at summing a large number of terms. Now, see, we have seen in the previous video how, for example, looking at this example right here, summing manually and going there can be tedious, and there's lots of room for error to be made because when plugging in numbers into your calculator, for somewhat reasons you might be pressing something that's totally not related, so it's time consuming, there's stress. But don't worry, we've got your backs. Okay, so basically, boys and girls, when summing a large number of terms, we have a formula that actually saves our butts. And in this formula, boys and girls, we're looking at this formula that is specific to a type of series or sequence. And this is specific to an arithmetic sequence or an arithmetic series. Now, boys and girls, when looking at this, boys and girls, when looking at this, we can then see, I apologize, someone just walked in and I had to just shout so that they could leave. Anyways, comic relief. Anyways, yo. So, boys and girls, when looking at this, one can calculate the sum of the first n terms of an arithmetic series by using this formula. I want us to quickly just dissect this formula before we tackle questions. Now, boys and girls, we did say that Sn is essentially the sum of the first n terms. Okay, it's the sum of the first n terms, and where n is the number of terms. So n is the number of terms. So, for example, they could say, calculate the sum of the first 14 terms in the sequence. Calculate the sum of the the first 74 terms in the sequence. Okay. Now, boys and girls, D, as we've seen here, we have encountered D. D itself represents the common difference, and we've seen this in our arithmetic examples and lessons. A will always be your first term. Alrighty. I want us to then move on to tackling questions, boys and girls. Now, the first question here, boys and girls, it says, calculate the sum of the first 30 terms of the sequence, and then it gives us numbers, as you can see, 3, 11, 19, and 27. So, first of all, step 1, let's find out what type of sequence this is, because we have to apply to a specific formula. So we see here that we are continually adding 8. And as we add 8, we can then therefore establish that we're looking at an arithmetic sequence. And we'll be using the formula Sn is equal to n over 2 multiplied by 2a plus n minus 1 d closed bracket. Now, boys and girls, we first have to have components of a formula in order for us to be able to apply a formula. Okay, so let's quickly state what we have. I'm going to use a different colored pen. So we said that we do have A. A is our first term, and our first term is 3. We have our D, which is a common difference. We did establish, and that is 8. And now we need N. Do we have N? So they said calculate the sum of the first 30 terms. So N is 30 because N represents the number of terms. So N is 30. And then we just quickly plug it into our formula. 30 over 2 multiplied by 2 times 3 plus 30 minus 1 multiplied by 8. And this, boys and girls, when plugging into my calculator, gives me 3,570. Easy as 1, 2, 3. Very important, boys and girls. Please don't forget to add your close brackets towards the end. Otherwise, it gives you a different reading. Alrighty. Now, moving on. Now, boys and girls, I'm sure you guys are asking yourselves, you gave us a freaking formula in the last lesson, but we haven't been able to apply it. You haven't really showed us where this whole formula applies to our lives. Well, I am going to show you today. Let's quickly go back a bit. Let's jog our memories a bit. Here we go. It says to obtain the number of terms from an what's it called again? From an example whereby you're given the question in sigma notation. To get the number of terms, we always say the top minus the bottom plus 1. The top minus the bottom plus 1. Know this formula. Nobody's going to give it to you, buddy. I am basically giving you that distinction. I'm saying, yeah, take. Okay. Now, boys and girls. Let's quickly see. They say calculate. We said that sigma represents the sum of, and then we're given the general formula, which is 7k minus 5. And we're starting from the first term all up till term 251. Okay. Now, what do we do in such a case? In such a case, let's see what type of sequence it is first. We cannot generally just assume it's an arithmetic sequence. And that's where we all just, lose the plot. Don't assume. Always ensure that you are correct. Try to be correct and thorough as possible. Okay? So let's quickly plug in to k, where we see k in this formula. Let's plug in our different terms. So, for example, 7, and then k is 1, because they start at 1, minus 5, plus 7. Now let's do term 2, so we put in a 2 in the bracket, minus 5, plus, now let's do term 3, 7 times 3, minus 5. Now let's do term 4, 7, 4, minus 5. Alrighty. That being said, we're just quickly gonna try, simplify whatever we've got going on here. So 7 times 1 minus 5 is essentially 2. And then 7 times 2 is 14, minus 5 is almost 9. 7, 14, 21, so 21. And then for the next, when dealing with this one, 21 minus 5 is 26. And then, am I proper? Am I saying something that makes sense? No, I apologize, boys and girls. This is a prime example as to why you should always use your calculator instead of mental math, okay? Yes. So 7 times 3 minus 5 is 16. I added instead of subtracting, I see. And then from there on, 7 multiplied by 4 minus 5 is 23. Now we could see, boys and girls, that we're adding something, yeah? We're dealing with an arithmetic. So essentially, 9 minus 2, we're adding 7. And then from there on, 9 plus 7 is 16. So we're adding 7. So we can see that we're continually adding 7. We are continually adding 7. Now, boys and girls, we've got this. We've written it out. So you saw that it was given to us in the what's called sigma notation. We write out a first few terms so that we could establish what our A value is. So we could establish whether we have a D and what our D value is. And then from there on, we could also establish, right, what formula we're using. So we could see it's an arithmetic one. So we're going to be using Sn is equal to n over 2a plus n minus 1d. Now, boys and girls, we have our A. We have our A, which is 2. We have our A here. We have our D, which is a 7. But do we have our N? No, we don't have our N. They didn't tell us like in the previous question. But I said to get N, we will always follow the formula. Top minus bottom plus 1. So therefore, N is equal to 251 minus the bottom, which is 1, plus 1. Therefore, N is equal to what? 251. Okay. So therefore, we take it out, and then from there on, so therefore, what we do is we then write out our formula again, and we just plug in. N is 251 all over 2. A is 2 plus n, which is 251 minus 1, and d is a 7. And then we plug it all into our calculator, boys and girls, and we get our answer from there. So let's quickly just plug it into our calculators. Now, excuse me, boys and girls, 251 divided by 2 is 125.5, 125.5, multiplied by 2 times 2, 2 times 2. Let's just quickly get this out of the way, boys and girls. 251 minus 1, 7. There we go. I get a good whopping 220127. Essentially, that's what I get. Please do try verify my answers, boys and girls. Don't take my word for it, because we are all human, and guess what? We all make mistakes. So do let me know in the comments if you happen to find something that maybe, or you might happen to find that your answer is contrary to what I am saying, or the answer I'm receiving. Okay. Now, boys and girls, let's do the last two examples before we conclude. Now it says, given the sequence to the nth terms, okay, given the sequence, so we're given a sequence, and they said that to n terms is equal to 72,710. So essentially, boys and girls, in this question, what they're saying is that we're given a sequence now, and this sequence has been added, and the sum of this sequence, boys and girls, gives us 72,710. So they're telling us, because of the plus sign, boys and girls, they're telling us it's been added, and they're giving us Sn in this case. So when given Sn, you're given Sn in this case. And we know that our Sn is equal to 72,710. They say calculate the number of terms in this case. So in this case, we're not calculating Sn, but rather we're looking for the number of terms that are equal to 72,710 when added together. Okay, boys and girls. So, boys and girls, we've write out our formula. But first, we're going to have to first establish what formula we're going to be using. We're given the sequence 2 plus 5. Apologies for my terrible handwriting. So we've got 2 plus 5 plus 8. Now, let's think. We see we're adding 3 here. And we see we're adding 3 here. What are we dealing with, boys and girls? If you do say something contrary to arithmetic, go sleep, buddy. This is not your day to shine, unfortunately. Okay. Anyways, boys and girls, Sn is equal to n over 2 all over 2a plus n minus 1. D is the formula we will be using. You better know this formula off by heart. So, boys and girls, here we go. We have our formula. We have our a. What is our a? Our a value is 2. What is our d value? Our d value is 3. Do we have an n? No. In this case, we are looking for n. Do we have Sn? Yes, we have Sn. Sn is 72,710. So let's plug in everything we've been given. So Sn is 72,710 is equal to n over 2 multiplied by 2. A is 2 plus n minus 1. D. Our d value is 3. And then we try simplify. Okay. So the best way we could simplify, or the easiest way we could simplify, boys and girls, here is essentially, because we have a denominator of 2 here, let's multiply both sides by 2, because we're multiplying both sides by 2, multiply by 2, and this would just cancel this one out. Okay. So we'd say 72,710 multiplied by 2 gives us this huge number, that being 145,420 is equal to n multiplied by, let's quickly simplify in here, 4 plus 3n minus 3, and then we will have again 145 145420 is equal to, if we simplify this, it would give us then 3n squared plus n, and then from there on we would use our quadratic formula, substitute this into your quadratic formula, and then, boys and girls, substitute this into your quadratic formula, and then from there on be able to solve. So we'd have 3n squared plus n minus 145420. Now, boys and girls, plug this into your quadratic formula. This would actually, if you plug this into your quadratic formula, it would be like this. N is equal to negative b, which is 1, plus or minus the square root of b squared, which is 1, minus 4a, which is 3, c, which is 145420. Boys and girls, apologies, I don't have space, all over 2a, which is 3. And this would give you two answers. Let me just quickly put it into the calculator, boys and girls, so that I can get my answer. 1 second. Negative 1 plus the square root. I'm using a different calculator, boys and girls, so just quickly just bear with me for a second, yeah? There we go, perfect. Negative 1 plus the square root of 1 squared minus 4 Boys and girls, please do me a favor and plug this into your calculators, because I'm actually experiencing a bit of problems here. And then from there on, what you should get is, you should get two answers. The answer you are to reject is a negative answer, because we do not have negative positions, but rather an answer that is a full-on whole number and it's positive. That's the answer. Okay, now, boys and girls, I want us to quickly move on to this one. Calculators give me problems. I'll sort that out as soon as possible. My main priority right now is just ensuring that you guys understand the concepts and the content is out for you guys to actually review and just consolidate your knowledge. Okay, now, boys and girls, it says determine the value of m if we're given a formula to a certain sequence, and it starts from t0. It starts from 0. It starts from 0. We put a 0 where you see I, and the sum of these terms, as we're told, is given to us as negative 671. Okay, so what we do is, firstly, 1 minus 3, we see an I, put a 0, plus 1 minus 3, we see an I, put a 1, plus 1 minus 3, where you see an I, put a 2, plus 1 minus 3, plus 1 minus 3, where you see I, put a 3, and we're essentially trying to just get to see what type of sequence we're looking at, right? Now, 1 minus 3 times 0, as when you plug it into a calculator, I get 1. And then these other ones, as you continue to try to solve them, I get 1 minus 3, which is negative 2. So it's essentially 1, negative 2. And then we move on again, 1 minus 6, negative 5. As we could see, it's like we're going more into the negatives. It's 9. We're going more into the negatives. So that, therefore, it's an arithmetic, but we're decreasing in an arithmetic pattern, okay? So we said that from 1 to negative 2, obviously, we've subtracted 3. From 1 to negative. Yes, we've subtracted 3, so it's negative 3. And here we subtracted 3. And here we've subtracted 3. Right. Now, A is equal to 1. D is equal to negative 3. And then, what else can we find out here? We're looking for M. Alrighty. So now, boys and girls, we said that to get N is equal to top minus bottom plus 1. Therefore, in this case, we would be having a case whereby we're looking at m, which is top, minus the bottom, which is 0, plus 1. Therefore, n is equal to m minus 1. Okay. Therefore, we'll take this, take all the information given, and plug it into our Sn formula. Sn is equal to n over 2a plus n minus 1d. Okay. So where's Sn? Sn is given to us here, boys and girls, as negative 671 is equal to m, which is m minus 1 all over 2 multiply by 2a. What's a? Our a value is, as we've seen here, our a value is 1 plus n m minus 1. What's our d value, boys and girls? That's negative 3. And then from there on, we solve. So negative 671 multiplied by 2 is negative 1,342, which is equal to m minus 1 multiplied by 2 plus 3 minus 3m, because remember, we essentially distribute everything here. So I'm just simplifying it, boys and girls, okay? In case you're just asking where I'm coming from. So and then we'll have again negative 1,342 is equal to m minus 1 negative 3m plus 5 negative 1,342. Apologies for being a bit tedious. And then we just distribute in as much as we can. So we'd have negative 3m squared plus 5m plus 3m minus 5. Therefore, 0 is equal to negative 3m squared plus 8m. And then we'd have negative 5 plus 1,342 plus 1,337. Therefore, we'd solve. M is equal to negative b plus minus the square root of 8 squared minus 4ac all over 2a, which is negative 3. Therefore, m cannot be equal to a negative. We're looking for a number. M cannot be negative. Boys and girls, just remember that. And m is a whole number. That's the answer you'd be receiving. Please do happen to have a discussion there in the comment section as to what the value of n is in this case and what the value of m is in this case. Now, boys and girls, you guys are blessed. You are able to do all things through Christ who strengthens you. Don't let anybody tell you otherwise. I hope you guys do know I believe in you guys, and I'm wishing you nothing but the best. Okay, so remember to take care of yourselves as well in this whole process. And cheers. Be kind to one another, guys. Cheers.